Today's going to be, I guess we're going to have a lesson, a small lesson, mashallah, on this science behind astrophysics, the sun, and a little bit of astronomy as well. Mashallah, I want to focus today on coronal mass ejection, which is basically sun's flares, and how they're basically directly related to the activity back here on Earth, subhanallah, um, uh, and how it causes um, the earthquakes as well as the freakish weather that we're witnessing. There seems to be a direct correlation between the two. Well, I'll obviously um, provide the evidence to that, and then inshallah ta'ala I guess you can also look it up. But I mean, I'm just going to quickly take you to the obvious I guess place to find out what a coronal mass ejection is. Wikipedia. And over here alhamdulillah, it says a coronal mass ejection, a CME, is an unusually large, I want you to focus on that, unusually large, so it doesn't happen frequently, by the way, unusually large release of plasma and magnetic field from the solar corona. They often follow solar flares and are normally present during a solar prominence eruption. The plasma is released into the solar wind, right, and can be observed in a coronographer, right, imagery. Now moving down further, you'll see the impact on Earth. Okay, when the ejection is directed towards Earth and reaches it as an interplanetary CME, okay, the shock waves of the traveling mass of the solar energetic particles causes a geomagnetic storm that it may disrupt the Earth's magnetosphere. Okay, now we're going to go to this particular segment, right? I'm going to draw your attention to this. It was basically a video of the H1 stereo of NASA on SETI, and this is a video caught for the 30 days of July up to August the 31st. What you see over here, mashallah, is the Earth. The vertical line running through it, ignore that. That basically just helps point out the Earth to us. On the left to us is our actual sun and the rays coming out of the sun. Over here, the top left of the screen, you'll see Venus come out, and I want you to keep your eyes on Venus as well, because you'll see some amazing activity on Venus in July. I've mentioned it previously, and I want you to see that activity because it is pretty phenomenal, and you'll see the relationship between the sun, its effects on the planetary bodies around it, and don't forget we are one of those planetary bodies orbiting our sun. Okay, take a look at this, mashallah. Also, you'll see an anomaly which doesn't belong in our solar system, which will also go past as well. And don't forget, this is a stereo satellite that NASA uses, and the video from it. Okay, look at Earth. That's the sun. Remember that the CMEs are very infrequent. In fact, I'll show you how infrequent in a bit from Wikipedia. That was one CME you just witnessed. That's the second. And did you see it hit Earth? Now this is Venus. Look at what's happened to Venus. Do you see that? That's a magnetic reaction to the reaction of the sun. That huge loop that you see over here, which is almost the size of Venus. Wow, subhanallah, right? It's unprecedented. And this happened just last month, right? And that was a reaction to the sun. And then you're seeing local reactions on back here on Earth, which is basically the storms, the freak weather, the flash floods, the tsunamis, the earthquakes, the volcano eruptions. Okay, so there seems to be a direct relationship between the magnetic waves being sent through the particulates from the reaction from the sun to Earth, right? Look at that, subhanallah. Did you see the size of that CME? Right, ajib. Anyway, so basically that's that. Now I want to take you to Wikipedia again, okay? And we're going to see a video of what NASA says this particular CME is all about. You'll see the model.
In this visualization, Earth's magnetic field structure is represented by lines that correspond to the paths charged particles would travel close to the Earth. The sun's magnetic field, carried in the planet or wind, flows continuously by the Earth, distorting the planet's field and pulling it back into a windsock-type structure. The red illustrates the higher density plasma which forms the magnetopause, the boundary between the magnetic influence of the sun and the Earth. The wind also forms a lower density magnetotail behind the Earth, represented by blue in this computer model. This process is happening all the time as the solar wind is constantly flowing by the Earth. But a coronal mass ejection, or CME, can change things. The higher density plasma and stronger magnetic field carried within the CME strikes Earth's field and significantly alters the structure. Here we see the dramatic changes in Earth's magnetic field and the shape of the...
Now, did you hear that? He said if the CME comes in, it significantly alters the Earth's structure. The structure he's referring to over here is the magnetic fields, both the northern and the southern, which is the negative and the positive. And these magnetic fields together protect Earth from harmful rays of the sun, radiation, etc. And they protect us from other stuff as well, but at least for the purpose of this particular video.
Magnetopause as the CME passes Earth. But close to Earth, the magnetic field is largely unchanged. Earth is protected from the intense solar event. This is the case for a rather ordinary CME.
This is the case for ordinary CMEs. So ordinary CMEs are lower in strength and they don't really impact us significantly. But what you'll see is, it will show an example on this model, what happens when there's a significant CME, the examples of two which I just gave you, which has happened last month, and correlate that with all the earthquakes that we witnessed on the surface of the Earth, as well as the storms and the freakish weather patterns as well. And what I'm getting at over here is the magnetic effect that a star has on us, and something's upsetting our sun considerably, because this has been happening this month, right? And again, I've been hypothesizing that there's another star that's come within close proximity to our solar system, to our sun, and that's upsetting our sun. And then that star at some point will get closer to us as well, and then we can only imagine what will happen then. Most of our time knows best. Anyway, I'll continue the video.
This example, a CME launched by an X3 flare from December 2006. But what would happen in the case of a more intense event, such as the Carrington event of 1859?
By the way, an intense event happened in 1859, right? And the example they're going to show here, which is exactly the same example of the two intense events that I just showed you, no less, a month ago. And this is in 1859, subhanAllah.
With the aid of similar computer models as before, we can explore some of these possibilities. Here, a much stronger CME compresses the magnetic field between the sun and Earth and generates more density in the bow shock, represented by darker red. The front...
Did you see how our magnetic field just literally disappeared and came right up to Earth, right? Touching it. So all that magnetic field is being pressed against us, right? And it can't protect us from the solar flare because the solar flare is so strong, right? And the magnetic field is so strong. And then what that happens is, when a strong CME comes out, it actually penetrates our atmosphere, but it doesn't just penetrate it. It actually goes through the core of the surface of the Earth into the core, which then, the core being iron, gets upset by the magnetic field, and then thus the earthquakes, the landslides, yeah? And then the atmosphere, of course, it touches the atmosphere as soon as it comes in, so it affects the vortices and the climate as well.
Of the magnetopause is pushed much closer to the Earth than usual. Even the field and plasma trailing behind the Earth are more strongly distorted.
Okay, so that's that. Now I'm going to take you somewhere else for a second. Actually, let me take you back again to that particular video, and let's continue to something that I do want to show you. Okay, because there was an anomaly there, which I forgot to point out. Do you see this? Right? This curvature is, well, it doesn't belong in the footage of this satellite, okay? I'm hypothesizing that that's a planet that actually shouldn't be within our solar system, okay? And that's actually the surface that you're seeing it, just like you see the surface of the Earth, where you see the curvature, the edge. This is the surface, it seems like, of a planet that actually doesn't belong Okay, because I mean this is the H1 stereo satellite. That's basically positioned to look at all the orbitals within our solar system. That's why you see them at a distance, all of these. Okay, that's Earth, right? That's Venus, by the way. It's positioned that way so it can see all the planets and part of the Sun deliberately. And they have some other ones as well, H1, H2, H3, but this is the angle that H1 is taking. H1 isn't near any other planetary body. Okay, it's at a distance deliberately so it can view every one of them at a vantage point within our solar system. So this particular body is something that's come closer to H1, and we have no idea what it is, right? And NASA certainly can't explain it away. So I'm hypothesizing that this particular curve is actually another planet that's coming in with this other star that's coming towards or already has entered within our solar system. And Allah subhanahu wa ta'ala knows best. Okay, so now I'm going to take you very quickly, just a few more minutes of your time, to this particular article. This is very interesting. The Telegraph today, which is the 2nd of August, has basically come out, and generally what they do to divert attention, and they want to localize it, rather than you getting to the bottom of the truth and finding out exactly how and why this is happening. You would have noticed that within the links and the documents and the evidence I've provided, I've also hypothesized that we're going to see frequency in meteorites entering our atmosphere. Interesting enough, this was posted today and yesterday, and it says the UK is going to witness. I mean, I've never seen this in my at least lifetime ever, that 200 meteorites are going to enter our atmosphere. Now, again, what I've been maintaining so far is that this planetary body and this star and its orbitals is going to drag along with it space debris as well as other meteorites, and it's flunging those meteorites into our solar system, hence why we're seeing the frequency of all the meteorites, one of which, notably, which I've mentioned previously a few times now, is the one that's hit Jupiter, and it's been documented, which caused a explosion the size of Earth, and that was just a couple of months back. Then we've seen enough enter. In fact, recently, just a week ago, a meteorite was witnessed in the States, I think in California and Los Angeles, and it was many meteors at the same time falling from the sky, and they blamed it on the Chinese satellite falling. And generally they do this. I mean, you'll find it that they'll basically take a detour and misdirect the traffic so that you don't really get to the point and connect dots. So I mean, again, over here they've kind of gone and blamed. They're saying it's going to happen on the 11th of August. Now I'm hypothesizing that we're going to basically float into, as we go on our orbit, into the debris field of these meteorites that have been dragged in by this star that's entered our solar system, and that's why it's happening. They're hypothesizing, at least their excuse, and they've said, and it's interesting. Look, the timing is very interesting. I mean, I couldn't have predicted this. What I had said is we're going to see an increase in meteorites falling from the sky. They've just come out and said, yes, we are going to. In fact, we're going to see 200 on the 11th of August, at least in the skies in the UK. But what they've done is they've not blamed it on. I mean, naturally, they don't want you to get to the conclusion that there's something not right, and the explanation they've given probably isn't correct. They don't want you to basically come to that conclusion, so they've explained it away by saying that this other meteorite that basically goes around the Earth on an elliptical orbit every 6 years has brought this debris field to us. Again, any explanations from NASA I would take with a pinch of salt anyway. Allah subhanahu wa ta'ala knows best, but I think you want to correlate the events with the CMEs that we've been witnessing with the earthquakes, and let's see if my hypothesis is correct or not. You know, I guess time will tell. Again, this is genuinely, it's not about being right or wrong, to be honest. I just think there's a serious relationship between this star that's coming in, the orbitals and planets that it's drawing in with itself, as well as the space debris, which is the meteorites, and then the relationship between it upsetting our sun, and then the sun having these nuclear fusion reactions on its surface, which is then causing these CMEs, these X-flares, and these X-flares, like they've themselves admittedly stated on Wikipedia, as well as by NASA's little model that I just showed you, very infrequent, yet we saw 2 of them and none of which has made the mainstream media. What has locally, which they can't really avoid, is people documenting floods, flash floods, earthquakes, and stuff like that. Along with this video, which I'll share the link to through WhatsApp, I'll also provide a snapshot of the earthquakes above 5.0 magnitude that have been witnessed worldwide in the last few days since the CMEs, and you see a relationship between that as well as the CME. And the question needs to be asked is what's upsetting the sun? And then there's obviously the halo that we've already recently discussed. Again, that halo shouldn't be up there. It's certainly not the ice crystals, because if it was something in our atmosphere, then we wouldn't see it above in deep space from the ISS images provided by NASA. I guess mistakenly, they're slipping up here and there and everywhere, and it's been picked up by some of the researchers out there. And Allah subhanahu wa ta'ala, mashallah, guide us to the truth. I hope, it's not the case. But again, like I maintained so far, the ulama genuinely seriously need to investigate this a little bit more seriously. I thought I'd make today's little video more scientific rather than just hearsay or theories. So we can hopefully maybe look to that and then take things from there, inshallah. Jazakallahu khairan wa ahsana jazaa for your time again. Assalamu alaikum wa rahmatullahi wa barakatuh.